Hello everyone, here is a question based on electronic configuration. Pair of transition metal ions having the same number of unpaired electrons is which one? Keep it in mind that electrons are filled in various orbitals according to Aufbau principle. Anytime you forget how to write the electronic configuration, keep this picture in mind. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and then put a slanting line like this. So this is how electrons get filled up in various orbitals. Now let's come to the question. Titanium 2 plus. Atomic number of titanium is 22. So for neutral element we will have 22 electrons. Therefore the electronic configuration is argon, that will have 18 electrons. So I am just writing it together, just a shortened notation, and then 4s2 and then 3d2. However, here it is mentioned as titanium 2 plus. That means now we have only 20 electrons. So where the electrons will be removed? From the 4s2 it will be removed, because here the principal quantum number is 4. This is the outer shell. So therefore electrons will be first removed from the 4s2. When it is getting filled, 4s2 will get filled first. But when it is getting removed from 4s2, it will be removed first. So therefore the electronic configuration is argon and then 3d2. Here we will have 2 unpaired electrons. Now let's come to cobalt 2 plus. So for neutral we will have 27 electrons. Atomic number of cobalt is 27. Therefore the electronic configuration is argon, 4s2 and then 3d7. So total 27. In the case of cobalt 2 plus, we are going to have only 25 electrons. So therefore now the electronic configuration is argon and then 3d7. So 3d7, if we fill up 1, 2, 3, 4, 5, 6, 7. Here we are having 3 unpaired electrons. So therefore this is not the correct choice. Let's go to the next one. Vanadium 2 plus. Vanadium atomic number is 23 for the neutral one. So 23 electrons. Therefore argon and then 4s2 and then 3d3. If it is vanadium 2 plus, we are going to have only 21 electrons. So therefore argon and then 3d3. So we are going to have 3 unpaired electrons. And then next, once again cobalt 2 plus. Cobalt 2 plus just now we checked. So therefore cobalt 2 plus and vanadium 2 plus both will have 3 unpaired electrons. So therefore this should be the correct choice. But let us cross check the other two also. And the next one is Fe3 plus. For neutral ion, atomic number is 26. So we will have 26 electrons. Therefore the electronic configuration is argon, 4s2 and then 3d6. 18 plus 2 plus 6. So 26. So in the case of Fe3 plus, we are going to have only 23 electrons. So therefore now the electronic configuration is argon and then 3d5, because 3 electrons are removed. So we are going to have 5 unpaired electrons here. And then the next one is chromium 2 plus. For neutral chromium, we are going to have 24 electrons, because the atomic number of chromium is 24. And the electronic configuration is argon, 4s1, 3d5. Why 4s1, 3d5? Because half filled and completely filled orbitals are more stable due to exchange energy. And therefore we should not write 4s2, 3d4. That is wrong. So this is something you need to keep it in mind. So for chromium 2 plus, we are going to have only 22 electrons. Therefore the electronic configuration is argon and then 3d4. So here we are going to have 4 unpaired electrons. Therefore this is not the correct answer. Let's go to the next one. Titanium 3 plus. For titanium, atomic number is 22. The case of neutral, the electronic configuration is argon and then 4s2 and then 3d2. If it is titanium 3 plus, then we are going to have only 19 electrons. Here we had 22 electrons, but when it becomes titanium 3 plus, we are going to have only 19 electrons. Therefore, the electronic configuration now is argon and then 3d1. So, only one unpaired electron we will have in this case. And then manganese, atomic number is 25. We have 25 electrons. Therefore, the electronic configuration is argon 4s2 and then 3d5. If it is Mn2 plus, then we are having 23 electrons. Therefore, now the electronic configuration is argon and then 3d5. So, here we have 5 unpaired electrons, and therefore, this is also not the correct choice.